Good evening, everybody. So, in this lecture, we will discuss on the discharge measurement using a triangular notch, which is known popularly as V notch, V notch or triangular notch. So, we discuss how to really measure the discharge in open channels using a triangular notch or V notch. In the previous class, we have completed the rectangular notch, and for the rectangular notch we have done for the general discharge equation. Then, considering velocity of approach, how the discharge equation modifies. Then considering n contractions, how the discharge equation modifies. So like that we derived and we solved some problems. So in this lecture also, we derive the equation for discharge in the case of a triangular notch or V notch, and then proceed further for the problems. The first one is discharge over a triangular notch. This is also called as V notch. Suppose if I draw the sketch, so this is a metallic plate where the opening is in the form of V, or the same we call it as a triangle. So this is the opening of the V notch. Right now the water level is up to here. So if I call this from here to here as H, right? Now if I take the central point, right? If I take the total angle as theta, second thing. Now what I will do, so like in the rectangular notch, here also I will take a small strip and I calculate what is the area of the strip. Then I calculate what is the velocity of flow through the strip. Then I calculate the discharge through the strip. Then overall discharge is equal to the integration of that. That is how we have done the problems. So if I take that, now for example, let H is the head above the, what you call it as, this is called as the vertex, right? Then theta is the angle of the notch, right? Now what I mentioned, consider a horizontal strip. Consider a horizontal strip of water of thickness, how much we will take, generally the thickness is dh, where it is located at a height h from the free surface, at a height h from free surface. This is the first thing. Now if I take it, for example, if the triangle, if I take it, this is vertical, suppose this is the V notch, right? Now this is how it is. If I take it, this is O, if I call it as, so from the center this is how much, h minus h, so this is the strip thing actually. Then if I take theta by 2 here, right? If now you take it, so what is tan theta by 2 is equal to, tan theta by 2 is equal to, right? Tan theta by 2 is equal to AC, if I call it as, right? That AC is what? This is A, this is C, this is B. So AC tan theta by 2 is equal to basically AC divided by H minus H, or AC is equal to H minus H into tan theta by 2. Why you have done this? Because I want to calculate the area of the strip. When if I want to calculate the area of the strip, I must know what is the width of the strip. If I know the width of the strip, then I can calculate the area of the strip. So that's why in order to calculate what is this, I have started that problem. So AC I got it. So what is the width of the strip actually? Width of strip is equal to 2 times AC. It is 2 into H minus H tan theta by 2. My next job is what actually? My next job is calculate what is area of the strip. Area of strip is equal to, it is a rectangle like. So width into 2 into H minus H into tan theta by 2 into height is how much? DH. So this is the area of the strip. What is the theoretical velocity? Theoretical velocity of flow is equal to basically how much is the theoretical velocity? The head above the strip is how much? It is small h. So head above the strip is h. So this velocity is due to a head of h. So that's why it is root 2gh. Therefore, dq is equal to, theoretical discharge is equal to the area of strip into the velocity of flow through the strip. So area of the strip is equal to 2 into basically h minus h into tan theta by 2 into dh. The velocity is root 2gh. Then basically, if suppose we integrate this, integrating this with limits 0 to h, because the head varies from 0 here to the full head here. So that means if you take, this is the V notch, right? This is the thing. So this we call it as h, right? Now this is the strip we have taken dh, and this distance is h. So now the limits for this h is, it varies from basically 0 at the free surface, and it varies to h here. So that's what we have put it. Therefore, q is equal to integral 2 into h minus h tan theta by 2 into dh root 2gh, right? And the limits are 0 to h. So q is equal to, in this 2 tan theta by 2, right, into integral 0 to into root 2g, also we take it outside. So what is there inside then? 0 to h limits, it is h minus h into root h into dh. So if I expand it, 2 tan theta by 2 into root 2g into 0 to h. Then if I take it, h root h minus h to the power of 3 by 2 into dh. So q is equal to 2 tan theta by 2 into root 2g into, now I will take it actually, even if I, one more step, if I write for the sake of students, it is dh minus h to the power of 3 by 2 into dh. So it is equal to, it is basically h into h root h dh. That means h to the power of 3 by 2 by 3 by 2 minus h to the power 3 h to the power of 5 by 2 by 5 by 2, because it is this 5 by 2 is nothing but 3 by 2 plus 1, and 3 by 2 is basically 1 by 2 plus 1. So this is how it has come. Yes, yeah. And limits are 0 to h. So if I do it, 2 tan theta by 2 root 2g into h into this h by 3 by 2 is basically, if I do it this 2 by 3 into h to the power of 3 by 2 means 0 to h, it is h to the power of 3 by 2 minus 2 by 5, right, h to the power of 5 by 2. So if again I do it, 2 tan theta by 2 into root 2g into 2 by 3 h to the power of 5 by 2 minus 2 by 5 h to the power of 5 by 2. So if I do it, then 2 tan theta by 2 basically into root 2g, right, into h to the power of 5 by 2 into inside 2 by 3 minus 2 by 5. So if I do this, actually what will happen, it is 2 tan theta by 2 root 2g h to the power of 5 by 2 into, it is going to be 4 by 15. So if I do it, it is 8 by 15 root 2g tan theta by 2 into h to the power of 5 by 2. This is Q. So therefore actual discharge is equal to CD into Q theoretical. It is CD into 8 by 15 root 2g tan theta by 2 into h to the power of 5 by 2. So this is the equation that we use for determining the discharge in the case of a V notch. If suppose, right, theta by 2 is equal to 90 degrees, that is a right angled triangular notch, then tan theta by 2 is equal to 1. Therefore Q is equal to CD 8 by 15 root 2g h to the power of 5 by 2. It is right angled V notch. Now next question is, this is the final derivation. So the final derivation is Q actual is equal to CD 8 by 15 root 2g tan theta by 2 into h to the power of 5 by 2. Next, what are the advantages? What are the advantages of V notch over rectangular notch? Kindly remember, first thing, for low discharges, for low discharges, V notch gives accurate discharge. Number two, in case of V notch, only one reading is enough to get discharge. Third point, actually, expression for right-angled V notch is simple. That is third one. And last one is ventilation is not required in V notch. So these are the four actually the advantages of V notch over triangular notch. Then the next thing is trapezoidal notch. What is a trapezoidal notch? Trapezoidal notch, if I draw it actually, so this is what we call it as a trapezoidal notch. This is how it is. So if you look into a trapezoidal notch is a combination. A trapezoidal notch is nothing but it is a combination of rectangular notch plus V notch. Now if you see it, for example, this portion is rectangular, this plus this is V notch. So using this, so what is the discharge in the case of trapezoidal notch? It is discharge through rectangular notch plus discharge through V notch. So that means actually it is CD1 into 2 by 3 L root 2G H to the power of 3 by 2 plus CD2, this is V notch portion, into 8 by 15 root 2G tan theta by 2 into H to the power of 5 by 2, where this portion is called L and this is theta by 2. So this is for trapezoidal notch. There is one small bit actually. What is Cipolletti notch or weir? What is it? Cipolletti notch or weir? Cipolletti notch or weir is nothing but actually it is a trapezoidal notch but with some specific thing. It's a trapezoidal notch, right? But it's a trapezoidal notch with side slopes, one horizontal to four vertical. That is first thing. Here it is if I take the slide slope one horizontal to four vertical. This is the Cipolletti notch actually. Remember, any trapezoidal notch with side slopes one horizontal to four vertical is what we call it as a Cipolletti notch or weir. The discharge over Cipolletti notch, the discharge over a Cipolletti notch is equal to discharge over a suppressed rectangular notch. Please, this is one of the points. Then one more point which we should remember is how to distinguish between a sharp crested notch, broad crested notch. So the basic thing is a sharp crest means actually it will be like this. If you see it, this is how the portion will be. So this is what we call it as how the water flows. So this is a sharp crested notch. Whereas here in the case of broad crested notch, if you take it, this will be like this. This is how it is going to be in the case of a broad crested notch actually, where it will be having a height z and it will be having a length L. So here it is not that. But if L is basically if you take this as H, L is less than H by 2, we call it as sharp crest. And L is greater than H by 2, we call it as broad crest. So this is one of the things that you should remember. And one more point is, for example, one small problem I will do in case of a triangular notch. If 1% error is committed in measurement of head, what is the corresponding error in discharge? So this is the next point. So what is it? Now if I take for a triangular notch, if I take it, what is the equation? 8 by 15 CD root 2G tan theta by 2 into H to the power of 5 by 2. Now if I take all this, it is all some constant. So I can write it as Q is equal to KH to the power of 5 by 2. What is dq actually? K into 5 by 2 into h to the power of 3 by 2 into dh. Then what is dq by q actually? dq by q is k into 5 by 2 into h to the power of 3 by 2 into dh divided by k into h to the power of 5 by 2. So therefore dq by q is equal to, it is 5 by 2 into dh by h, or dq by q into 100 is equal to, it is percentage, 5 by 2 into dh by h into 100. Right? If this is 1% actually, then what is, if error in head is, error in head is 1%. Therefore, error in discharge is equal to 5 by 2%, that is 2.5%. This is another problem actually, which we need to really understand. Then with this, I will stop, and next class I will do some 2-3 problems on this triangular notch. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.